Thinking about space stuff, are you? Well, Dylan is. He's always staring into space at this time on a Friday morning. Joining us, thanks very much to the Auckland Stardome Observatory. Morning, Dylan.
Morning, Wammo.
And today's all about curiosity, Dylan.
Yeah, Curiosity, which is the new craft from NASA which has been launched on its way to Mars. So, technically, Curiosity is the name of the bit that breaks off and goes down and lands on Mars. But the whole thing together, as it is now travelling through space, is called the MSL, or the Mars Science Laboratory.
Right.
So it consists of several parts. Curiosity is the part that goes down to land on the surface. And the first thing to sort of discuss, I guess, is the fact that it's very, very complicated to land this on Mars. It's including the two rocket thrusters which have already fired to get it out of Earth's gravity world, so to get it into Earth's orbit. It's going to take a total of 50 rockets working in coordination to be able to land it on the surface.
Right.
So very delicate, and everything has to go right. Although NASA have a history of getting these things right recently. So it's on its way. It's on its way to Mars now. It will arrive at Mars in August 2012, and then there'll be the nail-biting descent sequence.
Yeah, that'll be one to watch on the live stream.
Yeah, I mean there won't be a video of it as such. It's always hard thinking about watching things from Mars live because of course Mars is between 8 and 15 light minutes away. So the signal that it's sending out is what it saw. Or the signal that you're getting is what it saw 8 minutes ago.
Yeah.
So that's another big challenge of landing the thing.
But there's those tense moments in the control room where they're waiting to get a signal back from it once it's entered the atmosphere of Mars.
Yeah. They put it in Mars orbit where they can sort of stabilize it and make all the final calculations and trajectory adjustments, and then basically they just have to set the launch in sequence. You know, 8 minutes later, the go command will arrive, and then 8 minutes later, the response back saying yes, it's received that command will go. And so yeah, it is now biting.
So when you think about it, something that's eight light minutes away, it doesn't actually take that long to get there. When you think about it, you know, August isn't too bad.
No, about 7 months, 7 or 8 months flight. Yeah, it's not too bad. So it's sort of, I mean, most of the velocity that takes it there is Earth's velocity going around in its orbit, and it sort of slingshots off.
Yeah.
So the actual rocket power counts for very little of it. But of course, it depends where 8 minutes at best. It depends where Mars and Earth are relative to each other in their orbit. You know, they could be opposite sides of the sun, meaning they'd be about 400 million kilometers away.
Okay, so assuming that it lands successfully, what's next? What's the plan?
So it's quite a big craft, and it's going to drive around on Mars's surface and do all sorts of experiments. It's packed with scientific instruments. Now, technically, it's looking for habitability rather than life specifically. The chance of finding any sort of life has been mainly written off, but not completely. There's still this little chance left over from the Viking lander in the 1970s, which landed, and it did a soil sample which found some chemical results which had a consistency similar to bacteria.
Yeah.
Bacteria, or the activity of bacteria, or something very similar. So the initial sort of response to that was quite positive. Could there be traces of life, or life itself, in Mars' soil? Well, the fact that it's never been repeated by anything that landed on Mars, and no signs of organic molecules have been found by any orbiting spacecraft or landing spacecraft, have generally pretty much led the majority of scientists to believe that it was just a quirk in the instruments or a result of some sort of chemical process that we don't understand, some sort of unknown chemical reaction.
Yeah.
There is one scientist that worked on the Viking lander that still maintains that the results could be the signs of life, and he believes that Curiosity's instruments have the capability of confirming that.
Because that's something that the Mars rovers over the past few years haven't been able to do, right?
No, they weren't. I mean, they were wonderful things. They could do all sorts of things, but they just didn't have the depth of scientific equipment. They were a little bit too small, and they didn't have. One of the main limitations of them was that they couldn't actually dig beneath the ground. They could drill into rocks and things above the ground, but and take samples off the surface. They couldn't dig beneath the ground. So that's a big thing, because anything that was surviving on Mars is likely slightly below the surface, whether it is that presence of moisture, sort of not exposed to the very low pressures of Mars's atmosphere, or whether it is some in the far out case of some sort of bacteria being slightly protected from the radiation of the radiation that gets through to Mars's surface. So digging below the surface is one of the big things.
Mm-hmm.
And so, yes, and it's launched off there, and in 8 months we expect to know a lot more about Mars.
Cool. Well, I'm looking forward to knowing a bit more myself. So in the meantime, staring into the night sky at the Auckland Stardome, what can we see this week?
Well, not Mars. You can see Mars if you stay up a bit later. I think Mars is rising about 11:30 or 12 at the moment. So it'll be rising in the east as the world spins around. It brings it into view. It'll be distinctly red-looking star-like object. But the bright thing, there are two bright things either side of the sky in the evening. In the west, you've got Venus, and equally as bright in the sort of high in the sky to the northeast, you've got Jupiter. So they're the two bright things that sort of stand out in the evening sky. At Stardomes, they're still getting outstanding views of Jupiter through the Courtyard telescopes, where you can see the red spot, the bands of cloud, and usually all four Galilean moons, all four of Jupiter's large moons.
Mm. Great.
And if you can get a good view of Venus,
yep.
You can see the arc shape, because of course Venus isn't an illuminated circle like the outer planets. It's in a phase like the moon.
Mm-hmm. Great, sounds good. All right, head along to the Auckland Stardome Observatory. You can continue the conversation with Dylan on Twitter as well, twitter.com/Dylan Storey. See you next week.
See you next week. Wammo.